Okay, this is the second of the two videos on energetics chem 2, Hess's law and bond dissociation enthalpies. First of all, a summary of the Hess's law. Now you're either going to be given heat of formation data in your question, or you're going to be given heat of combustion data in your question. Whatever they ask you to calculate, just look for the data. The data, heat of formation, so your formula will be heat of reaction equals sum of the heat of formation of products, take away the sum of the heat of formation of the reactants, and that will give you the answer. If you're provided with the heat of combustion data, then just use this formula. The heat of reaction that you want equals sum of the heat of combustion of the reactants, take away the sum of the heat of combustion of the products. And simply by writing these two formulae, you will get a mark in your exam. Okay, right. So just use those two and you're bound to get the majority of your Hess's law questions correct. Okay, now just a couple of things I just want to say. Note that, for example, the heat of combustion of carbon, if you was to combust carbon, you're going to get carbon dioxide, and that is the heat of combustion of carbon solid. Okay, oops. Then if I was to ask you to write down the heat of formation of carbon dioxide, think about that. Heat of formation of carbon dioxide, you're making it from its elements, carbon plus oxygen. You notice that these two changes are exactly the same. Okay, and the same applies to this heat of combustion of hydrogen. Okay, making water, and similarly the heat of formation of water. So if I was to write water here, heat of formation, making water from its elements, there we are. So heat of combustion of hydrogen is the same as the heat of formation of water. The energy change is exactly the same. Alright, okay, let's move on to bond dissociation energies. Okay, now when you're given an equation, the first thing you must do is make sure it's balanced. Okay, so here's methanol, and I'm combusting it in oxygen, of course, to make carbon dioxide and water. And just make sure that's balanced. Okay, one carbon, 4 H's, one oxygen there, and 1.5 oxygen molecules will give us 4. That's 2 and 2. Yeah, 4. That's balanced. The next thing you should do, I recommend, is to draw the displayed formulae of all of your reactants and all of your products. Okay, only that way can you really be sure to see all the bonds that you're breaking and all the bonds that you're making. Okay, so list the bonds that you're breaking like this. Okay, and next to each one you write down the actual values, all right, from the table of data that they give you in the question. And similarly over here, okay, equals, you write down the values there, and you write down the total values there, and then you write down this formula: heat of reaction equals the sum of bonds broken minus the sum of bonds formed, and that will give you your answer in, I think it's going to be kilojoules per mole. Okay, and the sign, either plus or minus, will appear once you do the calculation, either minus or positive. Okay, bear in mind just a couple of things on this one. Right, first of all, the bond energies that you're given for each of the bonds, the carbon-carbon bond, the hydrogen, the oxygen-hydrogen bond, etc. These are all average values, okay, and they are averaged over a range of of compounds. So they are not accurate. So if you're asked to explain why there's a difference in the heat of reaction when you've worked it out using bond energies and as compared to, let's say, Hess's law value, and then this is going to be your answer. The energies that you're given are average values averaged over a range of compounds. Therefore, it's not going to be accurate. Okay, that's good. So we've covered then in these two videos, energetics 1 and energetics 2, the four things: enthalpy profiles, calorimetry, Hess's law, and bond dissociation enthalpies. Okay, so we'll stop there for this one.